different parameters, but you would do the same general idea for any discrete random variable. There's a better way to do it, but I'm not going to show you that. I'll leave it as an exercise. It's even faster than what I did, but just one thing at a time for the moment, okay? All right, last question on this part. Suppose that the vehicles on the on-ramp join the freeway where 1,500 vehicles per hour pass on average, okay? So 1,500 vehicles per hour. Let's convert it into minutes because the other one is in minutes. We have 10 vehicles per minute coming on the on-ramp. So here's our on-ramp right here. So we have 10 vehicles per minute on the ramp. So on the main freeway, we have 1,500 vehicles per hour times in 1 hour there are 60 minutes. So 1,500 divided by 60 is 25. Okay, so this equals 25 vehicles per minute. So these are the vehicles that are on the ramp, and 25 vehicles per minute on the freeway. So then afterwards, there are 10 plus 25 equals 35 vehicles per minute going down the freeway after the on-ramp. So the thing here is if we had this equal to x, if this distribution was equal to y, and this is Poisson 25, and x was Poisson 10, then over here we got z equals x plus y. The flow after there is distributed as Poisson 10 plus 25 because they're independent. So we need this independence for this to hold, for this property to hold. So, which is just Poisson 35. Okay. Now we can calculate, but we're still not there yet because we're asking what's the probability that no cars are on the freeway after the on-ramp for a 10-second period. Okay. So all of these other calculations, these were all for minutes. So we need to convert to a 10-second period. Okay, so we have 35 vehicles in 1 minute times 6 times in 1 minute there are 6 10-second periods. So this equals 35 over 6 vehicles per 10-second period. Okay. So if we take running out of variables, we have z there. So let's use, let's say, we'll go back to a. We'll loop back to a. So A is distributed as Poisson 35/6. That's the number of vehicles after on-ramp on freeway in a 10-second period. Okay. Take that. Then we want to find the probability that A equals 0. So we'll just use the definition. We have e to the negative 35/6 times, what is it? 35/6 to the 0th power here. So this whole term is just going to be 1 over 0 factorial. This is all just 1 equals 1. So so this is equal to e to the negative 35/6, which equals negative 35/6 equals, and raise the power to e. So 0.002928. Stuck. Zero zero 2928. And so on.